Hello, and welcome to my exploration of Lab 5, the effects of friction. Introduction. The purpose of this lab is to study effects of friction on a sliding object and calculating the coefficient of friction between an object and the surface it's sliding on. This lab relies on the Newtonian model of physics, which is made up of three laws determining motion. And this lab specifically relies heavily on Newton's second law to derive the velocity update and position update formulas. Now, jumping right into the results, I learned that the coefficient of friction between the block and a whiteboard is around 0.19. As you can see in the graph shown, which determines the x and y position of both the observed motion and the modeled motion, you can see the lines overlap almost perfectly, which means that the modeled motion is an almost perfect prediction of the observed motion. Physics principles. Newton's second law states that the net force acting on an object is equal to its mass multiplied by its acceleration. We can use the equation F equals ma to derive the velocity update position formula and the position update formula. In this specific scenario, as you can see, we slid a block down a whiteboard. The system is the block and the surroundings is everything else. For the physical model, we used Tracker to track the motion so we could create a graph of the x and y positions of the object. The initial conditions. The block started at a position of 0.4 meters in the x direction and 0.3 meters in the y direction and had a mass of 0.619 kilograms. By tracking this motion, again, we were able to create a graph of the x and y position. Now, this data can then be compared to a computational model where the coefficient of kinetic friction can be calculated. So, moving on to the computational model, we use the same initial conditions as the observed physical model to best predict the observed motion. This code creates a loop that predicts a mass's motion based off the net force acting on the object. In this scenario, gravity, the normal force, and the force of friction are all acting on the block. I manually edited the coefficient of friction mu, running the code several times until the predicted data aligned with the observed data of the block's motion. This is how I knew that I had found the correct coefficient of friction. You can see in the code how I have to add the different forces acting on the block together to create the net force, which then determines the velocity update and position update formulas. So what are the results? By using my computational model and aligning that data with the calculated observed data, I was able to determine the coefficient of friction between the block and the whiteboard. The coefficient of friction I found was 0.19, as stated before. Now some analysis. This is a reasonable value for a coefficient of friction between two relatively smooth objects and makes physical sense. Again, looking at the graph of the x and y positions of the observed and modeled data, you can see that the lines overlap almost perfectly. This shows me that my modeled data was a very good prediction of the observed data. This tells me that the value I found for the coefficient of friction is accurate to the real-life coefficient of friction between the block and the whiteboard. Now, what does it mean? What is the importance of being able to calculate coefficients of friction, and why do different material interactions have different coefficients of friction? Well, physicists want to calculate coefficients of frictions in controlled studies so they can use the value to predict motion in non-lab settings. The force of friction depends on the roughness of the materials acting on each other and how the shape of the molecules in the materials interact. This means that every single interaction of friction behaves differently when different materials are introduced. Physicists must find a coefficient of friction for each material pairing. Conclusions. This lab showed that physicists can use data from observed motion and predictive models to calculate a coefficient of friction for the interaction between two materials. This allows physicists to describe the value of mu between two materials, which can be used to later predict other kinds of motion between these materials. Thank you.